I'm Scott Allen Miller, and welcome to another Sam IT. Today, we're going to be talking about disk partitions and whether or not you should still be using them. This question came up pretty recently in a discussion group that I participate in, and it occurred to me that I've never talked about it, and very few people ever do. So first, a little bit of history. Let's go back 20, 25 years in storage. When we had a hard drive, we sometimes needed, and by sometimes I mean almost always, needed to break it up into hard partitions, into things that the system would see as logical drives but still existed on a single physical drive, and things that would be portable between computers. Just in case you needed to unplug a hard drive from one computer and plug it into another, those things needed to persist, so they couldn't exist purely in a controller or something like that. They needed to be actually on the drive somewhere. What was come up with long ago is the idea of disk partitions. And original partitions were extremely limited, and then later they came up with some extended partitioning to get a little bit more flexibility out of them. So really early partitioning in the PC world gave us only 4 hard disk partitions, and later we were able to extend them. It was unnecessarily complicated, and if you learned this stuff in the 90s, partitioning was particularly annoying, and the tools to work with it were always kind of complicated, and it made for a very non-flexible, a very inflexible system, is a better word, for dealing with storage, but it was very important. And if you read any of my stuff about disk appearances, the nice thing about partitions, this was the earliest really common thing that you would run into if you worked in IT starting in the early 90s. In most fields, partitions are the first place that you would run into any kind of logical subdivision of an existing physical drive. Instead of being forced to work with things at the drive level, you could create partitions, and these would create what appeared to the system as individual drives. If you're a Windows user, for example, one partition could become your C drive, another partition your D drive, and a third partition your E drive. Each of these to the system, to an end user, would just appear as another hard drive. But if you actually went under the hood and the literal hood opened up the computer and said, oh wait, there's only one hard drive in here. How is that? How do I have 3 drives showing up? It's because of partitioning. Now, partitions by design were not meant to be flexible in any way. Once you establish them on the disk, the size of them was set. Now, some of you who are experienced with partitions may come out and say, no, hold on, I know that I can modify them later to some degree. If I have a partition that has free space after it, I can grow that partition and potentially grow the file system that is inside of it and use that additional space. That is correct. You can have, under certain circumstances, the ability to grow a partition. Or if you actually cleared it out, potentially you could shrink it. But because the limits of the other partitions are hard set on the disk, this isn't a generally flexible system. So your ability to do that would be very limited, and it would be bound by other partitions. For example, if the first partition on the disk took up, let's say, 100 gig, and then you had a second partition on the disk that took up another 100 gig, and your first partition you decided you wanted to grow, the problem is that while you could move its barrier on the disk, it would then overlap with the second partition and corrupt your data. So you needed to have free space, and it only worked under very specific conditions, and it was always considered risky. You could do it, it's always considered risky. And lots of people lost their data because they didn't understand it thoroughly. So partitions were at best very convoluted and difficult to work with, and at worst extremely limiting, but they were the only tool we had at the time. By the late 1990s, the concept of logical volumes began to become very popular. And these exist primarily in 2 places. One is in the operating system. They still get written to disk as kind of a master file system or a meta file system that sits above the normal file systems and basically replaces the partition system. However, the partition system still technically exists, so you often end up working with a single large partition and putting your logical volume inside of that, a logical volume system instead of that, and then making volumes inside of that. Logical volumes are basically like soft partitions, and that's a good way to think of them. They're as if we had partitions, but we had more or less unlimited flexibility to alter those partitions. The advantage in the early days to hard partitions, to traditional partitions, is that they had very, very little system overhead because they were hard portions of the hard drive. If your drive had to move a certain distance on the drive, you would know you were within your partition. So they acted slightly more like independent drives because you would know hopping between them would have a performance impact, and you could control that in theory. With logical volumes, you don't necessarily know where they're going to sit on the disk, and so moving around on a physical hard drive could have some performance impacts that you can't predict. Now, some major things have changed since the 1990s when these technologies came out. One is that disks are just way faster, and so are computers in general. So there's a completely different behavior, and that overhead, which in the 1990s was enough that you could notice it, now is so little you would never notice it at all. And now that the majority of computers have moved to SSDs, those jumps on the disk are meaningless because you don't have a drive head to move around. You're just accessing different locations in memory. You don't have the same performance overhead. So essentially logical volumes have dropped to, it's not technically zero overhead, but it might as well be. Whereas in the 1990s, you actually were concerned that they may slow your system down a little bit because your hard disks were always the thing that kept you going as slowly as they did. Even in the 1990s, your CPU was rarely your primary bottleneck. Sometimes, but not most of the time, not for normal computing. So the logical volumes provide a lot of mechanisms that partitions do not. One is the ability to resize up and down on a disk. Another is quite often logical volumes are used as an ability to create snapshots. They're able to trigger quiescence triggers, API calls to the operating system and say, I need to quiesce this volume. And then they can use that to take a snapshot or whatever. Those are mechanisms that did not exist in partitions. So there's some features that can exist there, and often logical volume managers are places that are used to inject a compression algorithm or an encryption algorithm. So if you want to do full file system encryption or compression, often the logical volume mechanism is used to do that because you can do so at a block level that's very flexible and has a lot of logic and opportunities for algorithms to be triggered. And it allows you to have your file system or other mechanisms be completely blind to that, which is very flexible. It's very handy. Now, we mentioned that these things can exist on disk, but where else can they exist? The other place that we typically see a logical volume is on a RAID controller or a similar RAID controller if you ever come across one. With the RAID controller, you're able to create a RAID array and then separately take that array with many controllers and break it up into separate volumes. Sometimes these are referred to as logical disks or other things, but they are simply logical volumes, the same as you have anywhere else. They're just happening at that controller level and then being presented on as independent disks. So by doing so, they're able to present these disks to the operating system above them, and the operating system believes it has completely independent hardware disks. And for all intents and purposes, it does. It doesn't really matter that you don't actually have them. The system will behave as if it does. So this can be very handy, especially in labs. Now, the question will arise, which of these is better in two places? One, which is better? One, which is better? Should we be using partitions or logical volumes? And then the question becomes, if we're using logical volumes, should we use them on a RAID controller when available? Or should we do them at the drive level through the operating system's logical volume manager mechanism, which in Windows is dynamic disks and in Linux is LVM. Every system has its own name, but they're always a logical volume manager. That is simply what that layer is called. So to answer the first question, logical volumes every time. Forget that partitions existed. Don't actually forget, because you're going to need to deal with systems that have partitions on them from time to time, and you're going to still use them potentially in places like USB sticks. But in general, especially when you're talking about servers or professional workstations in an office environment, completely stop using partitions. They may seem like something important because we learned them so much during that era when the concepts of IT were being formulated, when the patterns that we were going to learn were being formalized. So we got a lot of discussion, a lot of training on partitions, and that has been passed down through mentor to understudy for many years. So we get this feeling like partitions must be really important still, right? The answer is no. They're pretty much a legacy mechanism. They were important at the time. There's nothing wrong. Yes, we all should have used them a long time ago. Today, we all should abandon them. They are just not flexible, and they are not giving us any advantages. So given that they have no advantages, but the logical volumes have lots of advantages, we need to move on to logical volumes. Logical volumes are just flexible and powerful and expected today. If you don't have a logical volume manager and you get on a server, A lot of times people will be like, but there's all these things I expect to just be able to do. Why are they not there? Don't cause that to happen. Use a logical volume manager. And there's more than one. There's LVM. Some systems like ZFS have a logical volume manager built into them. That's fine. Now, the other question is, where do we then put, given that we now know we got to have logical volumes, that's what gives us flexibility in our configuration, where should we put it? On the RAID controller when available, or should I put it into the operating system? This is a much more nuanced discussion. And for me personally, almost always I'm going to control it by the operating system. But that's more of a personal choice than it may seem. The more important piece here is if you have a separation of duty between the people who manage the hardware and the people who manage the platform, and the platform being whatever runs on top of that hardware. That could be a hypervisor, or it could be an operating system, or it could be that gray area where it's both, such as KVM. So if you're running like Ubuntu with KVM or Fedora or Debian with KVM, you've got an operating system and a hypervisor layer all mixed together. And so you call that person a systems person typically. Or if you're running VMware or possibly Hyper-V, you're going to be looking at it more from a platform engineering position rather than a systems. But in either case, whoever has that platform management on top of the hardware, if that's who you want to have managing that storage, then they're the ones who are going to need that. So they're going to need that in the operating system. You don't want them going into like an out-of-band controller in order to get access to that. That would be awkward for them and a workflow you may not want them to have for proper separation of duty and security in an environment, or just for good support practices. So the place where you tend to want that to happen is if you have a team that really knows their storage, you're going to want to put it over there. If you don't, and this is quite common, you have a storage team or a hardware team in the data center, and they know the storage and they know what they're putting in and how it's going to be shared, then you want them to do it. And common cases where that's going to happen the most is environments where you have mixed storage. So you may have the RAID controllers locally, but you may also have SAN controllers. So if they're working with SAN and already you have a storage team of some sort that is partitioning out to give to your platform and administration teams, then having this tool to allow them to do local partitioning in addition to remote partitioning with a SAN, for example, creates a uniform process where they, no matter what kind of storage it is, they're the ones controlling it and making purchasing decisions, capacity planning decisions, those kinds of things. And that would allow your platform and administration teams to have a uniform process where they simply request a certain amount of storage or say what they need it for and are given a certain amount of storage, and they never have to worry about it. Where it would be awkward is if you had a team that was managing a SAN and the administrators were like, okay, I need some storage. And then randomly you said, okay, but you need to hop onto an out-of-band management system and manage RAID controllers and storage, but not when it's SAN. So the only difference is if there's a network protocol. It starts getting weird. So think about that logically, how you want to separate the duties. If you're a smaller shop, which most of us are, and you're going to have your administrators and your platform people, your storage people, and your data center people all be one human, right? You're a one-man shop. All these hats are for you to wear. Then you have a different situation, and it's purely where do you find it more convenient to manage. And I'm going to lean heavily towards you want to manage it at your platform level, whether that's VMware, Hyper-V, KVM, or if you're actually putting an operating system directly onto the hardware, which I will essentially always argue against, but if you were to do that, you still want, it's so flexible to have that control at the platform / operating system level. That's where I will generally recommend putting it. But is it wrong or bad to put it on the RAID controller? No, that's absolutely fine. Both ways are okay. Whatever works for you, whatever tools you're comfortable with, whatever you feel you can document well and provides for your needs. For me, definitely, I'm going to do it at the platform level. Nearly always, and this is just personal preference, I'm putting on KVM with Debian, and I'll do all my management at that level. So I want my RAID controller, if I'm using a RAID controller, and that's another piece why I don't like to do it there, is I don't know that I'm going to have a RAID controller all the time. I may have a RAIN system, I may have a SAN, I may have any number of things. I want to get just bulk storage for the platform, and then I have a uniform process by which I can control all of that storage. But my administration teams tend to know a lot about storage and have no problem managing that. That's not true for everybody. You may have administration teams that have very light storage knowledge and don't want to know how to manage all these other systems down below, so you may want to shift that for those purposes. All of this I also talk about in my book, Linux Administration Best Practices, which, while it has Linux in the title and is certainly put into the context of a Linux administrator is a best practices book and talks about general storage, backup, partitioning, logical volume, and other concepts like this. If you want to support this channel and my work in education and IT, please consider going out to Amazon and checking out my book. That would help me a lot. I appreciate it very much. Thanks for joining me. Leave your comments below. Let me know, do you still do partitioning? Do you need guidance on where you would use logical volume? How would you use it? What tools would you look at? Do you use logical volumes? Do you like to use your RAID controller or your SAN or whatever? Or what are you using? I want to know. Talk about it below, like and subscribe, and I will see all of you next time. Everyone, I want to thank you so much for taking the time to watch this video and for all of you who have been supporting this channel over the many years that we have been here. I'm working really hard to get this channel back on track and get videos coming out on a regular basis. And part of that is something we've never done before, and that is give you guys a way to support the channel. It would be amazing if you wanted to do that, whether it's something as simple as giving it a like, a subscribe, and sharing with your friends, telling your coworkers or your boss or your company about it. All of that would be fantastic. For those who want to do a little bit more, you can buy me a coffee. Down in the links below, I have a link where you can go and support me directly. Any coffees that you buy is money that comes directly to me, so that's a great way to support the channel directly. You can also buy my book. Not all of you are aware, but I recently wrote Linux Administration Best Practices, and that is available on Amazon. That link will be below as well. That would mean a lot to me if you guys went out and purchased that. That really does help quite a bit. And for those who are looking for more than this channel does as a YouTube channel, I am a consulting CIO, and those that are interested can go to ntg.co, and that is where I've been for the last 23 years as a researcher, as an engineer, as a consulting information technology and operations director for companies of all types and sizes all around the world. Whether you need just a little bit of consulting, you need some advice on a project, or you're looking for someone to actually oversee all the operations of your company from a business infrastructure perspective, we offer all of that. Please reach out, sales@ntg.co. We would love to speak to you about what we can offer. Thanks so much for watching this show. I will see all of you next time.